Hello, I'm Simon Whelan from FenestraPro. Thank you for joining this course on our learning platform, which is an introduction to FenestraPro. In this short course, we're going to talk about a typical commercial building, particularly around the facade and how it relates to global energy use on a wider scale. We're going to talk about facade performance and some of the issues surrounding the optimization of passive considerations of your facade and your envelope. And we're going to take a quick look at FenestraPro, both the Revit add-in and the web platform, to show how you can design facades quicker, more cost effectively, and very intuitively. So to make a start, let's talk about the impact of a facade on a typical building. So this is a notional commercial office building, and we can see the different energy uses from this building. And if we look at the impact of the facade on some of those energy uses, we can see that heat loss accounts for about 12% through opaque elements like your floor, your walls, and your roof, and more through the glazing elements, given that they have a poor thermal performance. Lighting, or in fact, the lack of natural daylighting, I suppose, accounts for 19%. And then more active systems, such as cooling and mechanical ventilation, account for about 26%. So typically, this building, the facade to this building accounts for or influences about 57%, or well more than half of the building's energy use. So if we take a sort of a loose look on how that affects global energy consumption, well, we know that the built environment accounts for about 39% of global energy use, and commercial buildings account for about 19%, or half of that. And if we say half again is directly influenced by your facade on a commercial office building, we can see that about 10%, very loosely, about 10% of global energy use is directly influenced by your facade, and particularly by the glazing design to that facade. So when we're starting to talk about passive design strategies, I suppose that means we're looking at using geometry and materiality, or the form and the fabric, to reduce or remove the requirement for mechanical heating, cooling, ventilation, and lighting demand, those more energy intensive systems. So we're looking at energy efficient design, particularly around the facade. So we're talking about things like optimizing our solar gains. So that might be reducing the requirement for heating in winter months, depending on your your climate. It might be reducing the requirement for cooling around different seasons and different orientations. It might be looking at shading solutions and how they affect our solar loads at different times of the year again, and particularly around geometry or window to wall ratio, how much glazing we have, where that glazing is orientated. Or we might be talking about managing our thermal performance to create efficiencies around heating and cooling, building elements, the different prescriptive performances of glazing and wall systems, and again, the ratio between those two things and that window to wall ratio. Or we might be talking about the distribution of natural daylighting within spaces. So again, we're talking about shading solutions and whether that will restrict or reduce our natural daylighting. And again, you've guessed it, we're talking about window to wall ratios and the amount of glazing and where that glazing is situated. And these are all decisions that can be made at the very early stages of a project design. So then we're talking about those passive considerations. And, these are typically things that can work against each other: thermal performance, solar heat gains, and daylighting. Because if you think about it, the more glazing you have, the higher the heat gains you have. And that might work for you seasonally, or whether, depending on your climate, but the poorer the thermal performance, because glazing has a poorer thermal performance than opaque wall systems. Or the less glazing I have, it may be better thermally for my envelope, but I'll have a poor daylight performance within my spaces. So that sweet spot, that optimization is a difficult challenge to meet. It's a difficult point to get to, and that, optimizing between those three considerations. And that's where I suppose Fenestra Pro can start indicating and giving designers an understanding of the implications of their design decisions around these three considerations of your facade. So Fenestra Pro is very much about optimizing our facade performance without compromising the aesthetic design, dynamically in real time, and understanding as we make design decisions, what that might look like from the energy performance. So we're looking at the facade geometry. In other words, how much glazing versus wall I have, where that glazing is situated, whether there's shading included, what that shading will do, and materiality, what type of glazing am I using, what type of performances and properties that glass has. There's a good element of reporting and data so we can drive decisions and justify our decisions. Code compliance and some of the parameters around prescriptive performances or window to wall ratio are very much to the fore, so we can make decisions within those limitations that codes might restrict us to. And visualization and presentation, we can see what those performances look like, and we can see where they're applied to. So Fenestra Pro, from using it from an early stage in that design workflow, will very much streamline your design decisions. It will very much allow you to make decisions early and throughout the process to allow designers to maintain aesthetic control. We know that our decisions that we make will stick through the process, and whether it meet code or meet the requirements around performances that we're trying to achieve. And it's intuitive from concept to detailed design, from early conceptual massing right through to construction documentation. Fenestra Pro gives you the kind of data that you require at the time you require it. So let's dive in a little bit deeper and we'll take a look at some of the features and benefits to Fenestra Pro. Fenestra Pro for Revit supports building information models and data in the conceptual massing environment and also the detailed project environment within Revit. It will indicate shading effects on your facade and your surfaces from the building itself, any surrounding buildings, or any shading devices that are applied. It will give an understanding of the implications of code on prescriptive performances to drive optimal window to wall ratios at early stages or to evaluate defined glazing at later stages in the design process. Fenestra Pro for Revit will allow you to understand and explore internal performances that may affect building energy performance, such as daylight, solar heat gains, and we can look at annual or monthly averages or peaks and identify when those peaks happen. We can start populating our facades, both with curtain wall systems and window penetrations, based on geometry that we're trying to achieve or the optimal internal performances that we're designing around. We can intelligently search, filter and apply optimal glazing solutions from an extensive database within Fenestra Pro of glass types, both generic and manufacturer-led products. Through the FenestraPro web platform, you can import customized and bespoke glazing assemblies from our partners' solutions, Guardian Glass Analytics and the Vitro Configurator. On your account in the FenestraPro web platform, you can drive reporting and takeoffs to view and justify some of your design decisions, whether that be quantities, performances, or different materials. You can see all of the data in one place and then start customizing your reports to tell the story that you wish to tell. And finally, you can view more detailed thermal performance analysis of your glazing assemblies, looking at the difference of thermal performances between glass, solid systems, framing, mullions, etc., and see the implications of all those things and the average or overall U value of your assembly.